Okay, partial fraction decomposition. So basically, well, we're gonna break down this denominator here, okay? And what they usually do, they usually teach it in calculus too when you do integration, because you can do it by logarithms. So let me just see here real quick what let's see, I need a positive 2 and a negative 1 right there. Well, basically, to decompose a fraction like this, or I mean, well, it's not even, I mean, it's a rational expression, but to, I guess what we're trying to do is make separate terms out of it, okay? Now, so basically what we're going to do is we're going to go hunt down A and B, okay? And once we hunt down A and B, we'll be able to do a very simple integral of, like whatever over x over 2, and it usually turns out to be the logarithm of something. So I'm not even going to worry about that in my videos. I mean, we know how to do integrals. Let's just learn how to do partial fraction decomposition. Once we know how to break a rational down into partial fractions, then we're fine. Okay. So what I'm going to do is I'm just going to rewrite this. Okay. I'm just going to rewrite this on another piece of paper. And this first case is an easy one, and it deals with linear factors. Okay, and there's several different scenarios if you want to break a rational expression into term by term fractions. Okay. Now, when we say linear factors, notice that when I factored my original expression out, I have an x plus 2. That's a line, and an x minus 1. Well, that's also a line. Okay, so we're gonna assume that there is a way to do this. Okay, and so we'll just write it like this, like I have. The first thing we need to do though is get a common denominator. Okay, so we get the common denominator. That's all I really need to do. Okay, now that I got my common denominator, I don't even have to rewrite this denominator. So I'm just going to carry everything down. And the next thing I need to do is I'm going to multiply all this out. Okay, so whatever's in the top, I'm going to go ahead and multiply it all out. So that's going to give me ax minus a plus bx plus 2b. Now this 3, there's something kind of interesting about this 3 over here. Really, this is a polynomial as well. Okay, it's just missing some of its terms. Okay, well, or some of its terms have 0 as a coefficient. So basically what I want to do is I want to match up my x to the 1 terms. I don't have any x squared terms, but we'll see in a few more examples that happens. So basically, I will have a situation where 0x is equal to ax plus bx. Now, since I got x's on both sides, I can just divide them out, and I end up with a plus b equals 0. Okay, so whatever a is, b has to be the negative. Okay, just for observational purposes. And then my next my x to the 0 term is just a lone 3, and then here's all my x to the 0 terms over here. I got a negative a plus 2b. Okay, well this is just really simple to solve. And a matter of fact, since I have a negative a over here, I think I'm just going to go ahead and in this equation right here, basically I end up with a system of equations. Okay. Well, basically I'm just going to solve for b right here, so I'm just going to move a over. So that means b is going to be equal to negative a. B is equal to negative a, then 3 is equal to b plus 2b. So 3b is equal to 3. So the only way that's going to flow is if b is equal to 1. Okay? So it looks like a in this case is equal to negative 1 and b is equal to 1. Okay, now that's a really simple example. The hardest part of partial fractions is probably multiplying this out, you know, things can get messy, and solving the equation. Okay, so let's go back in here, and we had what, a was equal to negative 1. Okay, so, and I guess I might as well just rewrite this original expression because I have time still. So basically, you can imagine how integrating this would be a pain in the butt. As a matter of fact, I don't even know how you would integrate that, okay? But this would just be the negative natural log of x plus 2, and you'd just integrate the natural log of x minus 1 there, and that wouldn't be too tough. Or I mean, you know, the integral, you know, the antiderivative would equal that. I'm sorry, but like I said, that's usually the first place you see it. That's why they introduce you to partial fractions, is because it does make integration in some sense a little easier. Unfortunately, partial fractions are pretty tough, so I'm trying to put as many examples in as I can. Okay, and like I said, in those examples, I'm not even going to worry about integrating this stuff. I mean, we know how to integrate, you know, negative 1 over x plus 2. It's just, let's just worry about the partial fractions, you know, for now. You know, because you know, then we'll just go back to integration. Okay. All right. Well, thanks for watching. I got plenty more coming.